that continuity. Okay, this is in chapter 13.2. So what is continuity and how we can define that? That if you have any function definition, that for example, if I say a function f of xy, this is a function f of xy, and is said to be continuous at this point. For example, the point is given x naught, y naught. If the function at that point is defined and if the limiting value limit at xy approaches to the point x naught, y naught of the function xy is equal to the value of the function at point x naught, y naught. So when this condition holds, you can say the function is continuous. Okay, when this condition satisfies, you can say the function is continuous. Now in this case, you have any point. What you have to do, you choose one point, okay, and you put that point in the function, okay, and that point you got it, it should be defined. This is the first condition, and the limiting value of the function should equal to the that value. So similar, that is exactly similar what you have studied in calculus 101. Okay, now in addition to these things, in addition, if any function f is continuous at every point in an open set D, okay, then we can say, then we say that function f is continuous on D. And other thing is that if you say if f is continuous at every point, now in this case we have every point in the xy plane, then we say that function is continuous everywhere. Okay, so what does that mean? That if you choose any function which is continuous in the xy plane, this is in the xy plane, it is compulsory that it must be continuous at everywhere. Okay, if the function is continuous at every point in the open set of D, it must be continuous on D. So these are the conditions you must remember. Okay, so there is a theorem, you can say there is a theorem for finding the continuity of the function. So you have to remember this theorem. You have to memorize this theorem. Okay, so what is that theorem state? That if you have any function g of x, if g of x is any function which is continuous, okay, if g of x is continuous, at, for example, x naught, and another function is h of y, which is continuous at y naught, then f of x y, which is equal to g of x h of y, that is continuous at x naught y naught. Okay, that if you have any functions, any two functions, for example, this is function and it is continuous, which point? X naught point. And you have xy, which is continuous at y naught. And if you choose any function which is the multiple of these two functions, then it must that it is continuous at that point. Okay, because this function is two parametric function, so it must be continuous at the point. Okay, here it is continuous at only x point, and this is continuous at y point. Okay, this is the A part. Now talk about the B part, that if you have any function h of xy which is continuous okay at x naught y naught, and g of u is continuous at u is equal to h of x naught y naught, then the composition of a function f of xy, which is equal to g times h of xy, is continuous at x naught y naught. Okay, so what is the second statement says? This says that if you have any function h of xy which is continuous at x naught y naught, because this is two variable function, so it must be continuous at some point which is x naught and y naught. If you choose any point which is u, and u is continuous at this point which depend on x, so the function can be combined in this form, and you can say this is a continuous function. Okay, now the C part says that if you have any function f of xy is continuous at x naught y naught, and if x of t and y of t are continuous at t naught with x naught is equal to x into t naught and y naught is equal to y into t naught, then the composition f of x of t y of t is continuous at t naught. Okay, so this is the composition. Again, this is the composition. What is meaning by this one? That if you have any function which is continuous at this point, and if you choose only the variable x and only the variable y, that is continuous at both continuous at the point t naught. So you can write that x naught is the point which depends on t naught and y naught is this one. So their composition is also continuous at t naught, because x is continuous on t naught, y is continuous on t naught. So both the points are continuous at the same point, which is t naught. Okay, so we have to use these statements to prove uh, any function which is given to us, that either it is continuous or not, by using these statements. Okay, so now see one example. I will show, I will write here the example, that what is the example that show that the function f of xy is equal to 3x square y power 5 y power 5 and f of xy, which is equal to sine of 3x square y power 5 are continuous everywhere. Now this is the question. Now the function should be continuous. A part is this one. A part is that you have to show that f of xy, which is equal to 3x square y power 5 is continuous. Okay. Now, can I write that the polynomials g of x is equal to 3x square and h of y is equal to y power 5 are continuous? In calculus 101, you remember there is one statement that every function which is polynomial, it is continuous everywhere. You remember this statement? That every function which is continuous I will write in the chat. All the polynomial functions are continuous maybe you studied this statement, that all the polynomial functions are continuous everywhere. Now if I ask you to see this one, that 3x square, is this a polynomial function? Yes, this is a polynomial function. Y power 5 is a polynomial function. Yes, they are polynomial function. So that's why I say that if I take the separate function, they are continuous. They are all continuous everywhere. Okay. Now, by the theorem statement, you remember the first statement. So the product of the function f of x y, which is equal to g of x, is into h of y, which is equal to 3x square y power 5, is also continuous everywhere. Is this clear? Yes or no? Is this clear? This A part. Okay. Now see the B part. B part is that you have to show that function f of x y, which is equal to sine of 3x square y power 5 is continuous. You have to show that this one. Okay. From the part A, we already show that 3x square y power 5 is continuous. You remember from the part A, we already say that this is continuous. In x everywhere, so you can write in xy plane also, in xy plane. And sine of any variable, for example, you can say if sine of u is continuous at every real number u, so it follows from the composition function. Okay, it follows that if I write the composition, it follows that the composition composition f of x y is equal to sine of u is this one. So in the composition I write 3x square y power 5 is continuous everywhere. Okay, so this is the step. So we already know that this function is continuous because this is the product of two polynomials, and we already know that sine of u is continuous. So if we use the composition, that composition is sine of 3xy is also continuous. Okay, so this is the example that which you can use from the statement of the theorem that it is continuous or not continuous. Okay. Is this clear? Okay. Now, see, there are few more statements that how you can find the functions to be continuous. That is called the recognizing continuous functions. That how you can recognize that this function is continuous or not continuous. Okay. So there are three basic recognitions of the function. That the first one is that a composition of continuous function is continuous. Okay, just like similar the second part of the last example, that this function is continuous. Okay, the second part is that if you find the sum or difference or product of continuous functions is also continuous. Okay, in the first part of the example, you find that two functions are continuous, so it means their product is also continuous. Similarly, you can also find that if two functions are continuous, their sum is also continuous, their difference is also continuous, their product is also continuous. Okay. Now the third part is about the quotient rule. A quotient means if the functions divide the quotient of continuous function is continuous, but there is a condition, except where the denominator is 0, where the denominator is 0. That all the other points the function is continuous, but the denominator, where the denominator is 0, the function is not continuous. Okay. So these are the main conditions. These are the main conditions which we use to find the continuity of any function. For example, I give you any example of the function. Like for example, if you want to find the continuity of function f of xy, which is equal to x into e power xy plus y power 2 divided by 3. Okay, so can you check the continuity of this one? Solution. Function f of xy is equal to x into e power xy plus y into 2 divided by 3. Now, f of xy is the sum of two terms. This is the sum of x into e power xy and y into 2 over 3, right? Now, if you take only the first term, now if I take x and e power xy, is product of x and e power xy, right? Which are both continuous. So x into e power xy is also continuous. And now what is left? Now this one left. This function means y power 2 divided by 3. Okay, this function is also continuous. Implies the sum of the continuous functions x e power xy plus y power 2 by 3 is continuous. Got it? Understand? Because these are the two terms. First you use this one, and this is the product of two functions. This is continuous, this is also continuous, so you can say that the sum is also continuous. Okay. Is this clear? Yes or no? Okay. So, for example, Ibrahim, what didn't understand? Which one? Which part? Okay, see, I will explain in detail again. Just I write this function same. F of xy is equal to x into e power xy plus y power 2 divided by 3. Okay. Now see only this one. Forget this function. Okay. If you have only x into e power xy, this function is the product of x and e power xy. Okay, now forget this one, see only this one. Okay, x is continuous or not continuous? Can I ask from you, x is continuous or not continuous? Continuous means if you put any value in the function, that will give you the real value. If you put 1, it will give you 1. If you put 2, it will give you 2. If you put 3, it will give you 3. At any point, x is infinite? No. So it means x is continuous. Now talk about e power xy. E power xy is continuous because at any point of x and y, this is not infinite. Okay, any point you choose, that will give you some value of the number, right? Is this clear? Yes or no? Okay, now if they both are continuous, their product is also continuous. Why? What? Why? Faris. Faris, you have question? Yes, you want to write yes, or why you write? Okay, so this is their product is also continuous. Okay, so it means this thing we show it is continuous. Now talk about y power 2 divided by 3. Continuous means if you put here any value, it will not give you infinite thing. Okay, so either if you put 0, either if you put -1, -2, 1, 2, 3, any point, so this will be a continuous function. Okay, there is no break in that. So if this is continuous, the sum of, we know that the sum of two or more continuous functions is continuous. Okay, so it means the sum of this one and the sum of this value is continuous. So that's why I say this is continuous. Is this clear now? Ibrahim, okay. Now, if I write this function, can you tell me about the continuity of this one? F of xy is equal to xy divided by 1 plus x square plus y square. Can you tell me about this one? This is continuous or not continuous?
It's continuous, definitely.
It is continuous?
Yeah.
Okay, see, we will discuss that in detail. Okay, this is the quotient. Quotient means that there are two functions. one function is this one. One function is xy, and another function is 1 plus x square plus y square. Okay, see this one. This is the product of x and y. X is continuous, y is continuous. It means product is also continuous. So it means this is continuous. First, upper part, the denominator is continuous. Now talk about the denominator. Denominator is the sum of 1 x square and y square. 1 is continuous. Every constant function is continuous. Okay. And x square is also continuous because it is polynomial. Y square is also continuous because it is polynomial. So it means this thing is continuous. Now this is also continuous, this is also continuous. In the quotient, they are both continuous, and there is one condition. Anybody remember what is that condition for the quotient?
What, doctor?
For the quotient, that it must not equal to 0. This thing is equal to 0 or not? Any point, if you choose any point of x and y. So if I, for example, if I choose x1, x0, y0, that will give me 1. If you choose x is, for example, -1 and y is -1, that is also 1 plus 1 plus 1. So that is equal to 3. It means at any point of x, y, and z, it will not equal to 0. Okay, it will never equal to 0. It means they both points are continuous. So this is continuous. Okay, you can write all this on English, what you understand. Got it? So this is all about, for example, I give you one more example so it will be more clear. For example, if I write f of xy is equal to xy divided by 1 minus xy. Okay, now talk about this one. This is continuous or not continuous? Anybody can answer me this one. This is continuous or not continuous? Just a quick answer. Not continuous. At which point? This is continuous, but at xy not equal to 1 at this point, it is not continuous. Got it? Because when you choose xy equal to 1, the denominator is equal to 0. When the denominator equal to 0, it is not continuous. Okay,